All right. Hey, good morning, everybody. Welcome to the Hydros Engineering Math channel. Again, continuing our journey into the realm of math for operators. So today, we're going to build off yesterday's video. Hopefully today's video will have a little higher quality for you. We're just getting up to speed here, learning how to convert our videos. So today we're going to talk about a tank volume. So we're going to today talk specifically about a circular tank and how to calculate the volume. And we're going to build on these problems in terms of the complexity. But today, a relatively simple problem that we're going to look at. So let's just say that we've got a circular tank here, and that's important to know. It's going to be a circular tank, right? In the back, and the important things that we need to know are going to be primarily the diameter, which is going to be the width of that circle there, top or bottom, assuming it's top. Could also be the radius, and the radius, sometimes we'll give you the radius, and the radius is just a little bit different. It's half the diameter, so it's half that. So there's your radius. And then this blue guy down here, that is going to be our diameter. So same thing. So radius is equal to the diameter divided by 2. Okay? So that's important because we're going to need to figure out the area of this circle. So the other important dimension that we're really going to need here is going to just be our height. You know, how tall is the tank? Terms of our water level, and oftentimes your water level in a tank is shown as something like this, little like that. So this, we'll call this just little h for the time being. So that's the diameter or the height of our water in this circular tank. So generally they will give you some parameters such as the diameter of your tank is 70 feet. Or it could be the radius is equal to what? 35 feet. So it's half the diameter there. And then we'll just say that the height of the water, the depth of the water in that tank too, say like the overflow. So generally tanks need to have an overflow so you don't overfill them. And so the total height of the tank, of the sidewall here, is going to be some number, which I don't really care about. We really care right now about height of the water in the tank. So we're going to use our little h here. And let's just say that is going to be equal to 25 feet. So that's the maximum depth of water that we can have in our tank is 25 feet. So then what we need to do is figure out how we're going to calculate the volume. And if you remember yesterday, we talked in the video about area of a circle. And here where I live in California, the state has this handy dandy little cheat sheet that you're allowed to use on the exam, and they cover a lot of different things. So we're governed by the State Water Resource Control Board Division of Drinking Water when it comes to water, and we've got volume, a set of volume formulas here. And the important thing is, are we dealing with a rectangle or are we dealing with a cylindrical? So today we're dealing with a cylindrical type tank. And the area of a circle here, they shorten it up for us a little bit here in California and basically say it's 0.785 times the diameter squared. So we need to know, number one, we need to know a number of things here. So first, what we're going to do is we're going to start here, things that we need to know. So number one, we need to, let's draw a picture. Once you get enough practice with this, maybe the picture isn't quite as important, but I generally always draw a picture, whether it's on an exam or in real life. So we're going to use this guy over here is our picture that we've already done. Number two, we're going to think about our units. Okay. So one thing that we didn't ask in this particular question is we want to know the volume of water. Okay? And generally on the exam or, again, in real life, you're going to need to know, well, is it going to be in gallons? Is it going to be in million gallons? Is it going to be in cubic feet? Okay? So we need to know that, and we need to think about how do our units stack up. So today, pardon me, today we're going to calculate it first in cubic feet, and then we're going to convert that to gallons. Okay? And then we need to know what our formulas, what formulas we need. So here, we're going to need to know the volume of the tank. Volume in a circular tank. And if you flip a tank over on its side, right, if we were to flip that guy over, we have a pipe, right? So this methodology works if you're trying to calculate the volume of water in a pipe, which maybe we'll do that one for tomorrow, or a circular tank. We could have a square tank, we have a rectangular tank, all kinds of stuff. So anyway, so this is our basics here, what we're dealing with on our particular project. And we talked yesterday about the volume is going to be equal to an area times the height or length. Okay, so pretty straightforward here. So the area, now we're going to need to know the area of a circle in this particular. So first off, so we're going to calculate the area. So A of this circle is going to be equal to pi times d squared over 4. And we know what our diameter is. It's going to be 70. We know what pi is going to be, and we know what 4 is. Now, on that little cheat sheet here, they used 0.785 times the diameter in square feet. So that 0.785, so where does that come from? Well, on a quick little side note here, if you take pi, which is 3.14 over 4 times the diameter squared, that's the same thing that we just had up here. We just broke down what pi is. 3.14 divided by 4 is equal to 0.785 times d squared. That's how that little cheat sheet works. They're how they simplify that. But if you know the area of a circle, that's all you need to remember. Pi times d squared over 4. And if you're using radius, it's just it's going to be slightly different because this is equal to half. So it's going to be pi r squared times 4. Don't take my word for that. I'll break that down at the end of the video. Okay, so let's move on here. So we know then that our area of this guy is going to be equal to, let's just use our simplified 0.0785 times d squared, 70 squared. So 70 going to be equal to 4,970 squared is 4,900 feet squared times 0.785. This is going to be equal to 0.785 times that is going to be equal to, we're going to just call that 3,846 what? Feet squared, right? Okay, so let's go to our next page here. Gonna rotate that real quick for you. Rotate the 90. Okay. So now we know, going back here, 3,848. 3,900. I have a terrible short-term memory. 3846. 3846. Let's get in the habit of adding our units. That's how many feet squared, right? And then let's just revisit a little bit about what we talked about yesterday. There's our tank. We know this is 70 feet, our diameter, a 35-foot radius. But yesterday we talked about area is being feet squared. That's two-dimensional, right? Two-dimensional. So we know that this area up here is 3,146. So if you're flying over it in a little airplane, looking down on a circle, that's how many square feet you would be looking at. But we want to work in 3D, in volume. So areas are in 2D, whereas a volume is going to be in cubic feet, which is 3D. You go to the movies, you put on your 3D glasses, everything kind of pops. It's got dimensions, it's got depth to it, whereas 2D is just like a sheet of paper laying on the ground. 3D would be my coffee cup, my telephone, my wallet, things like that. So 3D. But 3D, so it's a volume, versus 2D, that's a squared. Okay? So we're going to then start looking at, going to add volume to this until we get to, say, our little overflow, right? So this is going to be our little baby H that we looked at before. And we said that was going to be, what, 25 feet? Yep, 25. So 25 feet is equal to H. So a volume is going to be equal to, we said, an area in feet squared times a H, a depth H in feet. Look at that. We have 2 feet here, square feet, foot. So lo and behold, this is going to break down to be a feet cubed, because you got to imagine that's a little 1 on there. That's feet to the 1. Okay, so we know that our area is 3,846 feet squared times 25 feet. Gonna get rid of that for just a sec. Gonna hold that. So 25 times 3,846 times is equal to 96,162 feet. What is it? Cubed. So that's the volume. The volume of water in here up to this overflow, this area in here, is going to be 96,162 cubic feet. Okay? So we have to be careful. Let's say the exam might have asked for it. So we did it in gallons. Or I'm sorry, we just calculated it in cubic feet. This was consistent with our units that were given as part of the problem. Okay? So you look up here, we had everything was in feet. So we drew our picture, we thought about our units, and we knew that, hey, we're working in feet here, and we're going to worry about converting these in a minute. So now we've figured out the tank volume, 96,162 square feet. Now for grins, let's convert that. So if we want to convert volume, cubic feet, to a volume of gallons, so these are all in volumetric units. A gallon by de facto is 3D. It's a gallon a jug, right? It's not just a flat sheet of paper. It's a cylinder, a carton, or a square, however you buy your milk, in 3 dimensions. So let's look at that. So we talked yesterday that if we had a cubic foot, here we took our gallon jug, whatever your jug looks like, and we fill that thing up. If this is a gallon, and this is 1 foot, by 1 foot. Look, there's 2 dimensions. That's the area of this front. And so we've got a height, a width, and now we'll go back here and look at this length. That's 1 foot. I got simple here because it's kind of small. I don't want to write feet, but that is 1 foot times 1 foot times 1 foot. These all have little ones on them. We're going to multiply the ones. Well, that's pretty simple. That's 1. And then 1, 2, 3 feet cubed. So we talked yesterday that this is going to be 7.48 gallons is equal to 1 cubic foot. You might see it written 1 cubic foot as well. All right, so 7.48 gallons. We're going to go into here, into that cubic foot. So let's do a conversion. And we talked yesterday about unit conversions, 96,162 feet cubed times, we want cubic feet on the bottom because this is acting just like a number, over 7.48 gallons. Okay? And unit conversions, we talked a little bit yesterday. So this is basically over 1. And you treat the foot cube just like a number here. So if I gave you something like this, 4 over 1 times 7.48, I just picked that number over 4. You would remember back in your old math days that this simplifies into 4 over 1 times 7.48 over 4. Oh, look at that. These will cancel each other out. Think of that foot cubed as a 4 right here. These are going to cancel out. So let me get rid of this. All right. So get that out of our way. And then we go back to our unit cancellations. And just like we were talking, think of this line as coming all the way across here. Like that. And then we're going to use the miracle of unit cancellations. The one is unitless here. And then this is going to simplify for us to 96,162. I should have put a little multiplication times 7.48 gallons are the only thing left. We got rid of the foot cubed on this guy, right? So this is basically unitless now, and the only thing we have left are gallons. So 96,162 times 7.48, 719,290. We're going to round that up. 6, what is it? Gallons. All right, cool. So 719,000 gallons. So that makes sense. A 70-foot diameter tank, 25 feet high to the overflow. Yeah, that's about 700,000 gallons. That's cool. And then to convert that to million gallons, maybe that's what the question is in. So how do we do that? So I'm going to get sloppy here. I'm going to say that 1 million, million gallons is basically 2, 3, 1, 2, 3 gallons. Okay. Pretty simple, right? You wouldn't even do this. You would just divide that by a million and say 0.72 million gallons. But this is kind of how it works, right? So it's another unit conversion. 1 million gallons is the equivalent of 1 million gallons. So we're going to put that here. And guess what? We're going to do some unit cancellation. Boom, boom. Okay. You can think of that like this had a 1 over it. So what does that equal to? 0.719 million gallons. And that's how we would convert that. So quick recap. Here, we drew our picture. We thought about our units. Hey, it was consistent here. Everything was in feet. We figured out what our formulas was. We needed a formula for a circular tank. And we go back to the basics. The basics are this. Volume is equal to some type of an area times the height, or it could be a length in the tape pipe. Then we came down here and we said, okay, well, what's the area? We're dealing with a circle here. Area is equal to pi d squared over 4. Pi is just 3.14. It doesn't matter. It's always 3.14. And diameter squared, given the diameter, if they'd given us a radius of 35 feet and we wanted to use this formula, we just say, oh, we convert the radius to a diameter. No sweat. Our state here in California gives us our cheat sheet. They basically give us the 0.785 times d squared for the area of a circle. This is how we got that. Area of a circle is just 0.785, which is 3.14 over 4. That's what this is. Our diameter squared, and we decided it was 3,846 feet squared. Carry that through. We know volume is equal to area times a height. We just plugged the numbers in. We did some unit conversions and came up with an answer, a 0.72 million gallon tank. All right, that's it for today. Again, as always, if you like us, subscribe. We're going to try to do this daily, at least 5 days a week. Try to take some weekends off and give us a like. Thank you all. Have a great day.